Welcome back to Chapter 1.2, Expectations, Variance, and Covariance as Geometry, Part 6 of 9. In Part 5, we ran Maya's 3 scenarios and watched diversification push her volatility below her safest asset, but she settled for an even split. Now we ask, what weight minimizes her risk? Because portfolio variance is a quadratic in the weight, it has a genuine bottom, and we can find it with calculus Maya already owns. That parabola, with a minimum, is the seed of modern portfolio theory and of the optimization in next week's regression. Maya does not have to settle for the even split. Since the portfolio variance is a quadratic in the weight W, she can find the weight that minimizes it, differentiate, set the derivative to 0, and solve. The minimizing weight W star equals the variance of asset 2 minus the covariance, all over the variance of asset 1, plus the variance of asset 2 minus twice the covariance. In scenario B, where the covariance is 0, this is 0.01 over 0.05 equal to 0.2. She should hold only 20% of the riskier asset. Plugging back in gives a variance of 0.008 and a volatility of about 0.089, lower than the even split's 0.112. The point is not the formula, but the shape. Risk is a parabola in the weight. It has a genuine bottom, and the location of that bottom is governed by the covariance. Optimization over a quadratic risk surface is the seed of modern portfolio theory, and we will meet the same parabola with a minimum when ordinary least squares chooses its coefficients in week 2. Here is the lesson Maya takes away. Expected return is a straight average. That is linearity from part 1. Risk is not, because of the 2w times 1 minus w times covariance term. The lower the covariance, the more risk cancels when you combine assets, and a negative covariance can push the portfolio below its safest component. Diversification is not magic, and it is not about spreading out. It is one term in one quadratic, and that term is the covariance. A lender like the ones Maya studies thinks the same way about a book of loans. Defaults that move together, a regional recession hitting everyone at once, are far more dangerous than the same number of defaults that move independently, even when each individual loan looks identical on paper. The sign and size of the covariance is the whole risk story. To summarize Part 6, portfolio risk is a parabola in the weight, with a genuine minimum whose location is governed by the covariance. Maya minimizes her risk by holding only 20% of the riskier asset, dropping volatility to about 0.089. The big lesson is that expected return is a straight average, but risk curves, and all the curvature lives in the covariance term. Diversification is one term in one quadratic, and a lender reasons identically about correlated versus independent defaults. This same quadratic with a minimum returns when ordinary least squares chooses its coefficients next week. In Part 7, we reveal that this covariance term is secretly the cosine of an angle between two vectors.